All right, let's get started. So today we'll be talking about all anagrams. Do a quick screen share. Do you want to lead off with any particular questions on this one first while I get a little screen share set up? Yes, Alon, we will. If you end up having found a solution using a hash table or a linked list or something, we would love for you to share it. But yes, for now, we will be going over an iterative approach. Okay. So the prompt was, given a single input string, write a function that produces all possible anagrams of a string and outputs them as an array. For the first part, don't worry about repeated strings. What's the time complexity? And then if you can get around to it, get it so that your function doesn't return any duplicates in the array. So if there aren't any Yeah, Antonio, an anagram basically is a permutation of the input string. Okay. So there are no other questions initially. The solution we have today is takes a bit of a recursive approach. So let me just walk through the code first real quick. So I didn't mention it's a recursive solution. So that means we have a base case. And the base case in this case is when the string that we give as input is of length 1. And then that means basically return just the string. And then we have this little start parameter as well. And we'll get to that in a bit, why that needs to be there. But yeah, again, so our base case is if the string is of length 1, and then if it's not, then that's when we initialize a new array for the anagrams that we'll be returning, and then iterate through the length of our string. And then for each one of those, we're going to be feeding in substrings recursively to our all anagrams function. I'm just going through this code like pretty quickly right now. We'll dive into it a bit more in a second. And then once you get the result of the all anagrams recursion, then you will push that onto the anagrams array, and at the end return that, and that'll be your completed anagrams array. Does anyone have any questions just kind of looking at the code itself before we dive a bit deeper into what it's doing? Some anagrams. Yeah. This one's difficult. Takes some mind warping a little bit with its recursiveness and unwrapping all that. So Antonio, the substring function here. Let me pull up the documentation really quick. So, yeah, this is the sub str function, and basically it's a method on strings, and then you supply the start index and then the number of characters that you want to pull off basically after, including the start index, right? So if we just do, so basically here string dot substring 0, let's just assume, so for example, if I was 0, then that means we are starting at index 0 of our string and then grabbing 0 elements. So if you did 0, 0, that means grab nothing, right? And then it gets incremented on as we iterate. It goes on to 1, so that means grab the character at index 0 and then grab one of them. So that just means grab the very first character at index 0. And then when I is 2, then that is the character at index 0, and then start there and then grab two characters. So the initial character that we started at, and then one more after it, and so on and so forth. And then if you don't supply the second argument to the substring function, so here we're just doing just single parameter I plus one, then that just means start at that index and then grab the rest of the string through to the end. So this is how we like break up the strings such that we're always basically grabbing. So we're like looking at a single letter and then we're grabbing all of the characters around it and then forming substrings out of those. Yeah, I'm gonna do a bit of a, let me stop sharing this one. I'm gonna do a bit of a whiteboard so that we can walk through this more clearly. Right, so if you all look along with the code, I can't really see it right now because it's behind the whiteboard, but so when we go through this iteration, right, so I'm just gonna kind of draw this out. So we have, oh, sorry, I forgot to say, let me clear this real quick. I forgot to show the function execution. So yeah, we just do all anagrams of a simple ABC, right? So return all permutations, all the different orderings you could have with the string ABC. So the initial string and then CB, and then with B and then with C. Okay, so.
Could you share the screen of that?
Oh, yeah, sorry. Yeah, so just showing the function execution, I console log the all anagrams function, the result of the all anagrams function, and then we get this array as a result. Okay, so go back to the whiteboard that I had. Okay, so with the string ABC, since the length there is 3, that means inside of this for loop, the outer for loop will be iterating through 0, 1, and 2. So I equals 1, and then I equals to 2 there. And then starting off with, when you have ABC and you do that within the first iteration, you go into the recursive call, and the result, basically the inputs that function will get, right, will be B, C as the start string, as the input string, and then start will be A. So basically what goes on here is start will be grabbing the character at that index of the input string, and then the rest of it will be the other letters, right? So then at I equal to 1, we'll have A and C, and then the start will be B. And then at I equal to 2, we'll have A, B, and then C. So this is what goes on in the first level of the for loop. And then if we continue on down into the bowels of the recursion, so there'll be 2 branches for each one of these, right? Because the input string BC or AC or AB is length 2. So for each one of these, there'll be another I equal to 0, and then I equal to 1 for the other ones as well. But then so in this case, I equal to 0, it's following the same pattern. So we get BC as the input string, and then so the all anagrams function at this level of the recursion will be getting C as the string and then B as the start. And then here will be B and C, and then we can fill these sides out as well. 1 second. Does this make sense though? How I'm like drawing out this recursion and what it's doing? Hopefully that makes sense. C and A. This one gives you A and C. This one over here gives you BA and AB. Okay, hopefully that's all right. Okay, and then now at this level of the recursion, since we're handing all anagrams single letters, just C and B, and then C and A, and then B and A, then the result that these return is just the single length string plus the start string, right? So this one returns CB, this one returns BC, CAAC, and so on and so forth. Right, okay. And so now that we've hit the base case of the recursion, then the recursive stack that we have going on basically completely unwinds. And so, oops, I want to stop drawing, whatever. Okay, so we've hit the base level of recursion, and now we get returned these results from the all anagrams, and then it has to go back up into the next level of recursion to basically finish those off, and that's where it starts pushing the all anagram, the results that we get back from these recursive calls to all anagrams into the anagrams array. And so we get back up to this level of the recursion, and then we have, it basically takes the start string and then concatenates that with the strings that we got returned, right? So here it would take the start string A, and then it would push A, B, and C, and A, C, and B. And then here it would be B, C, and A. BAC, because we have to go in this direction because it's unwinding it in stack order. So it should be BAC, B, C, A, and then here would be CAB, CBA. That should be the order that we got it back in, if I remember correctly. Yeah, it looks right from the result of when we ran it. So it's kind of the whole order of executions that's going on here with the recursion and the iteration. Does that make sense to you guys? What's going on here? And does like the way that I laid it out, does that kind of clear things up on how the recursion is happening? Okay. Okay. Anyone want to take a stab at talking about the time complexity of this function? If not, I'm probably going to pick on someone. Show the function. Oh yeah, sorry, I'm so bad at this. Let me stop sharing with that and go back to the code. Yeah. Yeah. So Jesh is right. It is actually factorial in this case because you're looking at every single string, and then you need to go. So you start off with looking at three of the. Let's see. So it was because okay, so we had all of these different recursive calls, and you saw that we had to go down to all the layers, and then within each of those recursive calls, we also had to iterate along the length of the resulting string that we got from each of the different recursive calls. I don't know if that's very clear, but yeah, Josh has a good it's a better way to show it than I was talking about.
Sean, one thought about the factorial complexity.
Yeah.
Something that helped me to get a feel for that was when I was trying to just figure out how to solve the problem, I just wrote out by hand what would doing A, B be, what would A, B, C, what would A, B, C, D, what would all those results turn into. And that's where I made the factorial connection, because with 2 letters you get 4, with 3 you get 6, with 4 you get 24, with 5 you get 120, and so on. And
yeah,
it took me a while, but once I realized, oh, that's a factorial progression, that helped me to go back to our original advanced JavaScript exercise where we did a factorial solution using recursion, and that helped me to wrap my head around the problem.
Yeah, that makes a lot of sense, actually. That's a really good explanation. Better than I could have given. Yeah, so I think hopefully that makes sense to the rest of you all as to why that is the case. Again, better than how I could explain it. Cool. If there are no other questions about this code challenge, okay. So Alan is saying solution only supports 8 letters due to 90K call stack. Let's try 10 letters. Sure, why not? We can try blowing the call stack. F, G, H, I, J, K. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'll go 10 and see what happens. It's probably going to take an absurdly long time if it works. Yeah, okay. Program was stopped because it seemed like, oh, sorry, was this shared? I think it was shared. Okay, it is shared. So potential hit into an infinite loop.
That's probably the REPL stack controller. That's the handler for REPL trying node.
Yeah, sure. Antonio asks, this is a probably pretty common interview question. It's kind of hard to say, frankly. Whether it's common or not, it should definitely be a pattern that you are familiar with and used to whipping out, I would say. But yeah, I can't actually really speak to like how common it is. That's a little harder to gauge. People just ask what they like to ask. So,
hey, Shan, I got an interview from Virus Dev, they're 1% of 10,000 recruited, and like 80% of the things we saw till now going in the algorithms test. There was a topic called algorithms, but they are they are harder than we got here. Like even occurrence was with letters. Do you guys remember the even occurrence exercise? It was with letters and numbers. And if you found a letter, like if the previous letter was A and current letter is C and next letter is B, I should rearrange this as ABC. So besides even occurrence, I need to count how many occurrence. Like if you have 3 times the same letter or number and they are like lesser one than another, I should consider the lesser. So they put like another level, but they don't make like not real world interviews. They don't have made like not real world because it's not a real world situation. You can't use this in a real world.
Right,
I
and
mean, I
a
think
lot of interview questions are like that
this is more.
actually.
I think this is more for practice algorithms than to learn how to iterate over it.
Yeah,
Because you can't iterate.
yeah, that's actually pretty
That's
common.
that's that is exactly why I asked to see this in a different way, because it's, I mean, if this is asked in an interview, this can't be answered with recursivity because it will blow the stack like in the 5 or 6 ladder.
Yeah, again, Alon, feel free to work on that on your own, but we sadly just don't have the time to go over that. But if if you come up with a solution using that kind of approach, we would love to have you share that with everyone else. Okay.
I have a linked list that is pretty close to work, that is working with 3 ladders. But if you put the 4 ladder, I need to flag the middle node. I don't find the middle node. Like I go to breadth first and then depth first, and in the middle of it has the 4th value if I put the 4 ladder, and I can get it because I need to flag. I will see how I will approach it.
So Wesley in the CS1 channel says, I did this problem by creating a tree, and that solution was able to do the problem with 10 characters. Wesley, would you actually be willing to show us your code in like the short amount of time we have left? Because I think people would be really interested in seeing something like that. Cool. That would be pretty awesome. But yeah, like just so you know, guys, like just because we show you a certain type of solution or a certain type of implementation doesn't mean that's like the canonical way to do it, right? Like there's so many ways to solve all of these different problems. So hopefully you guys don't feel like limited by just the way of thinking that we kind of lay out a little bit through the single solutions that we kind of just give to you guys.
I saw some solutions that were pretty mathy when I was trying to wrap my head around this, that are faster than O to the factorial order. I think there was one that used some famous mathematician's equations that was actually a linear progression.
That's pretty cool. Yeah, and there's definitely tricks like that that require a lot of prior knowledge.
The fastest approach I found was with hash table in C++, but I can't translate. I don't have the patience to understand and translate to JavaScript, and I don't know hash table enough to it, because I know that my implementation of hash table is not exactly what it means, and I need to study it. But I'm pretty sure that hash table is the fastest and less operation way to do this, because you can iterate over the index. You have the current, you can trespass by based in indexes. You have 4 indexes and you can sort the 4 indexes, like going directly to the trespass. The way the guys made it in C++, or recursively trespassing each index with another and sorting it. Like total unreal, like total out of sense. It's totally randomic, his algorithm. So I'd really love to see it in JavaScript.
Yeah, and so keep in mind, guys, that the solutions that we give to you guys can't be too crazy, because from an instructor's point of view, we kind of need to cater more to like kind of the average of the class, right? So for those of you who like are really into optimizing these and going with like much more complex solutions, like feel free to do that on your own time, but just try to think about it from an instructor's perspective. You know, we don't really have the time nor even really the resources to present those to you guys in that kind of way.
Yeah, but this one that is pretty way that doesn't work in real world should have at least not a presentation, but at least the working example from you guys. Like, you can't use this way in real world, so we definitely need to see it in a different way. And I'm doing my best to implement it in a working way different than it, but it's pretty hard. You guys are most experienced, so we'd really expect that you guys provide us a different approach on situations like this.
The problem with that is that combinatorics is an entire field of study all on its own. So you could really go and get a whole master's in it. So it would be very difficult for us as beginners to understand it. At least that's my understanding of it.
Yeah, that's
Kind
why
of, yeah.
I asked extra credit from the teachers. Like, I'm telling they don't have to pass it to the class, but they have to provide the example, because we will not found by ourselves. Or, I mean, that is pretty easier if you just pass us the example.
Algorithm, you'll get his, like, a whole explanation of how he does it, and it's the fastest way we know so far. So, I mean, if you're really into combinatorics, there's a lot of resources out there for it.
Yeah, and there are a lot of like resources on the internet as well for this kind of stuff along. So you can just continue to do research and stuff like that as well, and that would probably get you into a certain direction. Okay. Anyway, so that's all we have time for this for today. I think now you guys you have dedicated project time, so you should continue working on the HTTP AJAX sprint. And then brown bags at 1. So we'll see you guys there for that at 1 p.m. All right. See you guys later.